Let's examine this figure a little more closely. You've heard me going on and on at you about the horizontal axis. It must be drawn to scale, and I'll say that once again, just in case anyone's forgotten. The variable is income, the units are thousands of dollars, simple enough, but you must draw these figures so that they have the right relation to each other. For example, if a width of 50 looks the same as a width of 10, then you will end up showing that 1 is equal to 0, and we really don't need that kind of excitement. It's the vertical axis that I want to look at. Units percent per $1,000, because we took the area that was the percent and divided by the width of the interval that was in thousands of dollars, and let's take a look at what that means. The first thing I'd like to do is I would like to look at the bars without any numbers in front of me, and I can see clearly that the first one is taller than the second one, but I can also see that the second one has a bigger area. This thing just looks bigger to me. Let's just confirm that and then try to understand what the height means then, because it clearly means something different to bigger area. Here's the table again, and here is confirmation of what we were seeing. The second bar has 28% of the people, the first bar has 20%, the second bar just has more people. Percents are represented by area, so it has bigger area. The first bar is taller, 2 versus 1.87. So in that case, what is height measuring? We know that the 10 to 25 bar has more people, but it is shorter. And what we've learned from this is what heights are not measuring. Heights are not measuring the percent of people. Areas are doing that. Heights are measuring the percent of people per unit on the horizontal axis. In other words, how many people per unit of space. And what is that? People per unit of space. That's crowdedness. Heights measure density or crowdedness in the interval. The 10 to 25 bar has more people, but it is shorter, and that means it has more people, but it is less crowded. That's just like the United States having more people than Japan, but being less crowded because it has correspondingly much more room. Let's go back to our picture and see what that is telling us. What I'd like you to imagine is the 20% of the people in this interval all trying to stand in the space between 0 and 10 here. And the 28% of the people in this interval trying to stand between 10 and 25. Certainly, there are more people in the second interval than the first, but they have correspondingly more room. So while these people are standing elbow to elbow, these people have a little bit of more breathing room, and you can see that by the height. Less crowded, more crowded, less crowded. And take it to the extremes, this 7% of people in the final interval here are standing over 50 units of space. They can stretch out and go for a little walk. The least crowded bar of all. And now I'd like to look at the top of the histogram, the flat tops of the bars. What are the data? The data are saying 20% of the people are in the interval 0 to 10, but they're not telling us what percent are in the interval 0 to 5, for example. So if we make the simplifying assumption that those 20% of people are evenly spread over this interval, which is reflected in this bar having a flat top, the same height throughout, then under those assumptions we can do some calculations within the bar. For example, under the assumption that the 20% are evenly spread out here, within each $1,000 interval, you have 2% of the people. That's what the height means. 2% per $1,000. So if I say what percent earned between $5,000 and $6,000, that's a $1,000 interval here. 2% of the people earned in that range. That is, of course, under the assumption that the people are uniformly distributed over this interval, and that assumption is less reliable the wider the interval gets. So you have to keep in mind that the calculation, there are 2% of the people in the 5,000 to 6,000 range is an approximation, and it will be as good or as bad an approximation as your assumption of even distributions. Taking a look at the numbers again, what we can tell by the discussion that we've just had is under the simplifying assumption that people are uniformly distributed within bars, 2% have incomes in the range 5 to 6. So what percent have incomes in the range 5 to 7? Well, that's 5 to 6, followed by 6 to 7. And so 4% have incomes in that range. This is an interval of width 2. And for each one of those units, you have 2% of the people. And so then 4%. If you look at the next interval, then in the range $14,000 to $15,000, that's a $1,000 increment in the second interval. You have 1.87% of the people, roughly. And to summarize, if you assume uniformity within bars, which may or may not be a good assumption, then you can figure out the percent in subintervals. The percent in a subinterval is the height of the bar times the width of the subinterval. Now that's really not rocket science. The percent is an area. It's the area of a rectangle, and so its area is the height of the rectangle times the width of the rectangle. No big surprise. In the next section, we'll use this calculation to estimate what are known as percentiles of the data.